be sure you warm up for some exercise over here. Good afternoon, everyone. Welcome to this talk. It's about ASP.NET SignalR, and the title of this talk is around real-time web made simple. So before we get started, how many people are using SignalR today? Awesome. How many people have heard about SignalR? Cool. So hopefully what I'm going to show you is going to be something that you can relate to and sort of go back and start building applications. It's going to would make more sense. So does anybody have any special requests for this talk? Like, is there anything in particular that you want to see? Or have you heard about that you want to discuss? So keep this thought in mind, like as we go around for the next 75 minutes. If you have questions, you want to discuss anything, feel free to stop me and we can have a conversation around this subject. It's a pretty exciting topic, so I do want to give people an opportunity sort of to think really hard about, like what does this make sense, like where would I use it, and how can I benefit from SignalR. So that's why I really encourage you to sort of stop me and ask questions if you have to. All right. So let's do some introductions and we'll get started with our presentation. How many people from here are from Spain? Okay. I'm going to try my rusty Spanish, which I learned for a day, and you can tell me if I'm correct or not. I'm going to start by saying basically, mi nombre se Pranav Rastogi. Is that correct? Ah, yes. Okay. So my name is Pranav Rastogi, and I'm a program manager on the ASP.NET team. And our team sort of owns these set of frameworks and tools that a web developer would typically use to build applications. So if you've heard about ASP.NET, MVC, Web Forms, Web API, Entity Framework, like SignalR, that's kind of what my overall team sort of works in. And for myself in particular, like this is the first team or first job I've ever had in my life, so I'm pretty excited about this space. I've been working in this space for the last 5 years. I started with Web Forms and sort of gradually migrated to like MVC. I worked a little bit on SignalR for the 1.0 release, and now I'm sort of working on the authentication/membership story for ASP.NET. I am an occasional blogger, so I'll probably blog once about 2 to 3 weeks. But I do plan to blog about this talk. I'll upload all the slides, the demos, and everything on my blog. If you need to reach me, you can send me an email on my work address, or you can contact me via Twitter. We can have a conversation on this subject, or in general, if anything that you want to discuss. And more recently, I think I was very excited that I got an opportunity to sort of write a book as well. So I have a newbie title to myself of co-authoring an ASP.NET 4.5 book as well. I am originally from India, so my accent might seem a bit weird. I've had trouble, people back in the United States sort of picking up my accent, and especially on my name. I don't think they've ever got my name right, and each time I go to Starbucks, I get a new name, basically. So that's how it goes. In my free time, I do like to travel a lot, and I do like to experience different cultures. And this picture is sort of from a trip I made to Brazil, and we went out fishing for piranhas. I managed to somehow catch one, and I almost got bitten, but nonetheless, I still survived. So if you want to talk about fishing, anything else, like kind of hang out after the talk. So what is SignalR? Simply put, like SignalR is an incredibly simple real-time web framework for .NET. We've had some frameworks for other platforms, like we've had Socket.io for Node, but we have not had anything that makes it really easy for building real-time applications for .NET. And the three overarching themes that I want you to take away with SignalR is it's all about simplicity, it's all about reach, and it's all about performance. Like those are the three key tenets on how you would describe what's the pitch. Like why do I care about SignalR so much? And most of my demos are going to be focusing around simplicity and reach is what I'm going to like sort of bring home the point that that is why you should care about SignalR. So how simple is SignalR? Let's sort of jump back to our Visual Studio and see for ourselves what does the getting started experience look like for SignalR. So I'm going to create a new empty project. And I'm going to download this NuGet package. Are people familiar with NuGet packages? Yes? Awesome. A year back, the answer I used to get was no. So I had to spend like 5 minutes explaining what NuGet was and why did you care about it. But it's good that it's catching up. So I'm going to download a package called SignalR sample. This is a package that the team maintains. And this is basically a quick demonstration of what SignalR is capable of. So I'm going to install this NuGet package. It's going to bring down a bunch of dependencies for SignalR. There are not too many. And I don't have to worry about it because NuGet sort of takes care of it. So once I install this package, I can close it. I can sort of build my solution. And what this application is a basic stock ticker. So imagine how stocks prices can change in real time, and you get sort of notifications around it. So let's run the application to see how it would look like. So I'm going to launch it in multiple browsers. So if you didn't see that, there was a feature in VS where you can right-click and you can browse with, and you can control multiple browsers to launch your application with. So it's a pretty handy feature that got shipped with the Dev 11, like VS 2012. So go back to my browser. I have IE and Chrome side by side. So I can open the market, and what's happening is basically there's a fake stock service running, which is pumping data back to the application. And as the stock prices keep changing, there's some animation that happens that the stocks are going up and down. It looks like Microsoft is going up. Good. That's a good sign. Apple's going down. So it doesn't reflect the true price of the market today, but it's a fake stock ticker. The idea behind it is these two browsers are sort of synchronized to each other. So if I hit the close market button, you would see that if I hit it in IE, the Chrome one also gets disabled and the whole market stops. I can start the market again. I can have any number of clients connected. I can even go ahead and sort of add devices as well. So I can launch an iPad, and I can browse the same URL. And let me just refresh all my browsers so that everything is in sync. So now I'm sort of connecting devices as well. So that's what SignalR is. Like, it adds this real-time capability so that you can build applications and you can target different platforms, you can target different devices and stuff. So I have basically browsers running, and I have like native clients running on the iPad and the Windows Phone and stuff. So do you believe that it's simple? Yes? Wow, you're an easy crowd to please, man. Okay, well, so this was a good introduction on what SignalR is. Let's actually build something to really see what it means when we talk about SignalR being simple. So I'm going to close all my browsers, and I'm going to write a demo, which is going to be a move shape. Has anybody seen that demo before? Just one. OK, perfect. So what this demo would do is basically it will show you an object on the screen, and you can sort of drag it around, and it's going to get synchronized across all the browsers and across all the devices as well. And as part of this demo, what I want to highlight is the concept count that you need to know about while writing SignalR applications, and the amount of code that you have to write to wire everything up. So that's the two takeaways I want to have with this demo. So I can go back to my application. Let me just create a new folder called Move Shape. Okay. And this could be anything. And I'm going to add a new class to it. I'm going to call it Move Shape Hub. So what Move Shape Hub is going to derive from a hub. And hub in the SignalR world is a server-side abstraction where you can basically listen for messages from the clients, and then you can push messages to the clients as well. So you can think about hubs as being like controllers in MVC or like pages in web forms. So they're high-level constructs. They build on intrinsics of HTTP. So web forms builds on handlers, and MVC builds on controllers and stuff. So that's what hub means in a SignalR world. It's a high-level server-side abstraction. So I can come over here, and I can sort of attribute my hub with a different name. And the reason I'm sort of giving it a different name is because once this hub gets exposed to all the clients, then the clients will call this hub by the name that I will give. Like, I don't want them to call them by the class name that I give. So I can specify a name. And then I can write my server-side logic. So I can write any method, so public void move shape. And it takes in x and y coordinates of the shape to be moved. And so this is a method that's going to be called by all the clients. So any JavaScript client which is on the browser or any .NET client like WPF application can call this method, and they can pass in the arguments of the particular shape. And what my hub is going to do is basically, if there are multiple browsers connected, it's going to broadcast this message to all the connected clients, letting them know that the location of this object has changed, so they should do something. So that's all my hub would do. So we have a notion of clients. And I'm going to say, like, for all the other clients, so if I send the message, I don't want to update my own location itself because I know my updated location. I just want to notify everybody else. So client.others.shapeMoved. And all this is dynamic, like these methods don't exist. I'm going to basically I'm going to be making a remote procedure call onto the clients once. I'll show you once we move to that part. And I'm going to just pass in the x and y coordinates. So that's it. So that's all I have to do on my server-side code to basically listen for incoming messages and then broadcast these messages over to all the clients. So let's write a client as well. So I'm going to add an HTML page. Since I don't have any server-side processing, I'm going to just create an HTML page over here. And I'm going to start bringing in some script references because JavaScript is the future. So I have jQuery, which I bring in, and then I bring in jQuery.SignalR. So jQuery.SignalR is basically a plugin that the team has written so that SignalR can work on top of jQuery. So it uses jQuery as a foundation, and then it plugs in the client-side story because of that. And then I'm going to add a reference to a magical file. And I'm going to talk about it a little bit more in detail later on. So I'm going to call it SignalR/hubs. And so what this magical file will have is, it will have the proxy generated for all my server-side code. So it will know that I have a hub called moveShape, and the hub called moveShape has a method called moveShape. So that's the information that this proxy will have. So that's all the libraries I wanted. I'm going to create a shape object, this is something I'll move. And now I'm going to write some JavaScript code to create a connection between the browser and the server. So that's what I'm going to write right now. So I'm going to say var hub equals $.connection. And so $.connection is a SignalR intrinsic, and it basically holds the instance of the connection. So I'm going to say moveShape. And so let me pair these guys side by side as well so that you can see what's happening. So moveShape is basically the name of the shape that I just put on my hub. So this creates a connection between the browser and the server. It doesn't start it just creates a connection. And the call that I did on my server was basically, if there's an incoming message, then call this shapeMove method in all the connected clients. So I need to define this method in my JavaScript. So I'm going to say hub.client.shapeMoved. And basically, it's saying when this method is called, it's going to pass in an x and y. And let me define my shape object. So all this is standard Java jQuery shape. And so once this method is called, this means that somebody moved a shape, it got called to the server broadcasted it to all the clients, so the client should update the location of that object. So that's what this code will do. So shape.css, and then I'm going to change the left with X, and then I'm going to change the top with Y. Okay. So that's all the code for handling the events on the client side as well. And now the two things that are left is I need to start the connection, and each time the shape gets moved on the browser, I need to let the server know that an event has fired. So those are the two things that have happened. And if you think about it, like, I should not send any message to the server unless the connection has started. So the first step I should be doing is basically starting up the connection as well. So we have $.connection.hub, which basically gives you an instance of the hub that you just created. And I can start the connection. And what I'm going to build now is basically some constructs which exist in jQuery, the concept of promises and sort of building onto it and chaining on events so that once one event fires, then the other one can happen if the first one happens successfully. So once start happens successfully, it's done. Then I'm going to call a function. And inside this function, this basically is a place where I have a guarantee that the JavaScript has loaded, the connection has been created successfully. So now I can handle my events of dragging the object onto my page. So I'm going to make one more change. Save it. I am going to download jQuery UI since I'm going to be dragging this object. So I'm going to quickly go to NuGet and get jQuery UI. Nowadays, it's become so easy to sort of bring libraries into your project. It's pretty amazing. So add this reference of jQuery UI. Okay. And once the connection has started, then I can sort of define my $shape.draggable event. And inside this, I can have the drag option. And I can say for the drag option, so whenever you notice that the jQuery UI, basically this object gets dragged around, I am now going to call the server method of moveShape. And we're going to pass in the x and y coordinates. So this dot offset left, this dot offset top. If it's out of the bounds, then just pass in 0. Okay. Right. So that should be it. Oh, I missed one thing. Yeah. I need to style my div so that it's visible on the page. So I'm going to just style it poor man's way of setting the background color to be green. You can also give it some width. So it looks like a square. Width is 100 pixel. Let's do the height as 100 pixel. Okay. Sync compiles. Don't see any obvious warnings. Let's browse. Sorry? Did I miss something? Okay. There you go. So I have a synchronize across browsers. And the amount of code, let's open these files again. So this was the amount of code that I basically had to write. So this is roughly about, I don't know, 10, 15 lines of code, and I have sort of real-time communication set up in my application. And I think the part that's sort of unique about this application is, and I sort of glossed over the details a little bit over here. If you think about what I'm doing over here is So normally, if you think about web applications, you always push data from the browser to the server. That's easy. It's form over data, you post back, and stuff happens. Sending back from the server to the browser, it's hard. Like nobody has solved that problem. Like people default to other mechanisms of polling, AJAX, like long polling, server-side events. But having to set up a framework in such a way where it sort of becomes part of your regular web development, I think is a huge step, which is what the realization I had about this experience. So that's the best aspect of using SignalR is the simplicity of getting up and running fairly quickly with these scenarios. So close all the browsers. Let's go back to our slide. Great. I moved a block. How do I use it in my applications? Like, can I use it in real apps? Like, so that's the question that everybody asks. Is like, it's a cool demo to do is one thing, but what's the practical implications of using SignalR? Like, why do I care? Like, how can I use it? And I think the way to think about this question is, any time in your experiences or in your web development you've seen customers or people, your users, do F5 in the browser, that's the space where SignalR can like come in handy and solve that problem. Like, anytime an update needs to happen, it should just be seamless. It should just happen. Like, a user actually should not have been required to sort of force a browser update to happen. Some very practical examples where sort of SignalR have started being used is collaboration. So if you think about, like, you can do online collaborations with OneNote, with Excels, with Word docs and stuff. Like, how do you figure out like what parts of the documents have changed and sort of merge these conflicts? And you have to do it in real time. Like, if you're going towards a world where you're connecting with multiple devices across multiple platforms, I think this avenue sort of becomes very interesting of giving the feedback in real time. So that's an important space to be in. Dashboards and monitoring is a great example as well. If you go to the Windows Azure portal, that you will see that each time you create a website or an event happens in a website, it sort of updates itself automatically. Like, you don't have to refresh the browser again. Like job progress, like you submitted a job or you uploaded a picture, or you uploaded an image. So the feedback loop of like how much percentage has happened, that dialog was always lying to us when it said 90% and still half an hour was left. Like, so those scenarios can be improved, like going further, is basically you have real-time feedback on what the progress is. And something else which sort of should relate to a lot of people is about real-time forms and concurrency management. And what this is about is forms over data applications. So this is an application which many people have written, which are behind firewalls, which have no jazz in it, but are traditional forms over data applications. And the problem these applications still face is, how do I manage concurrency? How do I manage conflict detections? What do I do when I have conflicts of data? I think what we sort of resort to by default is we use optimistic concurrency. And what that leads to is, if the guy before me updated the data, and I'm the one that's updating the next, I'll get exceptions. Like, I'll either get a yellow screen of death or some glorified exception. And the space where sort of SignalR fits into this world is, like, imagine an experience where if both the grids are sort of connected via SignalR, then we have information that there are two people editing the grid. And based on this, sort of we can present them with a richer UI saying that, hey, this person updated with this data, do you want to merge it? And sort of provide a UI in the form itself, rather than like throwing exceptions. So you can provide more richer experiences in this space is an avenue that's open as well. And the last one, which is sort of unique in this space, is gaming. And when you think about gaming, we always think about games on the Xbox consoles. Like, that's what we think about. But what this sort of highlights is I can have a multiplayer, real-time, collaborative game running in the browser. And that's what I'm going to show you now is this game called shootar.signalr.net. It's live, so if any of you want to play it on the Surface with me, they are more than welcome to. So this is a game which is written by the SignalR team itself. So I can go to SignalR, shooter.signalr.net. And this game sort of is highlighting the kind of applications you can build with SignalR. So it's a high-frequency game, and it's a shooting game. So I can go move around, I can come back, and I can shoot. I can sort of boost my nitro and move faster. Oops, what happened? So what this game is sort of demonstrating is it's using i10, it's HTML5, CSS3, JavaScript. That's all it has. There's no Flash, there's no plugins. And it's using the awesome canvas capabilities of I. And so this is what we call a high-frequency game. And by high frequency, what we mean is there's a server-side component. And so the server-side component is basically refreshing at the rate of about 25 hertz. So for each second, for each user, it's sending 25 updates from the server side. And on the client side, the refresh rate is about like 5 hertz. So for each user, for every second, there's the 5 updates getting sent. And so the demonstration over here is basically the power of SignalR in terms of this is scale out as well. Like it's hosted on Azure, like it's I think a normal size VM. And for those of you who don't like the keyboard or on the Surface devices, you can also do touch. So I can come over here, and if I get it right, then okay, yeah. So I see these. I can tap on the bottom, the side bars, and sort of navigate with my 2 fingers around. I'm not super good at it. That's why I was having a little problems over here. But the point being that this is the kind of games that we envision that people would start writing with real-time collaboration. This is an online multiplayer collaborative high-frequency game. So that's an interesting application that we're going to have with SignalR as well. It's open source on GitHub, so you can go check it out. It's run by the team. So that's an area where SignalR can, or such applications can generate quite a lot of interest. Okay. Any questions? All right. So let me continue. Is it simple enough? Can we make it more simple? Okay. So the simplicity sort of lives in these 2 high-level constructs. I showed you hubs, and hubs, as I was mentioning earlier, is a high-level construct which I think most of the web application developers will use because it provides the most convenience layer of writing applications. It does basically a remote procedure call between a client and a server, and there is a JavaScript that sort of gets automatically generated. I'm going to get to the JavaScript in a bit. The other construct that we have is called connections. And so connections are sort of the lower down building blocks of SignalR, and hubs basically build on connections. And the key difference between connections and hubs is basically when you use hubs, all the data that is sent over the wire is serialized into JSON. And so you can serialize, deserialize objects into JSON and sort of transfer it. With connections, it's all strings. You send strings and you receive strings, and that's it. So you have to deal with all the conversions yourself. And connections sort of support this broader range of APIs where you can broadcast to all clients, groups, individual. You can sort of think of chat rooms where you can join different groups in a chat application. So we have that feature in SignalR as well. And there's a lot of connect, disconnect, reconnect, like scenarios which connections enable as well. So let me show you an application that we can build using connections, and then sort of compare what the difference would be of using a connection versus hubs. So I'm going to go back to my project. And first, what I'm going to show you is I'm going to just launch this in, yes, please. Okay. So let me do browse with, okay, yeah, browse. Chrome. So I'm going to just F12, and I'm going to show you the hub / SignalR / hub. So what this basically is, let me zoom in. So it's basically it's generated at runtime, and it's basically the proxy of the server-side code. So if I were to scroll down, it basically has my proxy for SignalR. If I keep scrolling down, then you would see that it has my move shape hub, and it has a definition of the move shape hub. It has one function called move shape, which the clients can call. I had the other stock ticker hub as well, so it defines all the client-side and the server-side functions to it. So it's basically a proxy generator at runtime. So that's what that magical script does. So I'm going to make another demo, and no demo is complete without a chat application in real time. So I'm going to make chatter, and I'm going to use connections. So I'm going to create a new class. It's going to call it chat connections. And instead of inheriting from hubs, I'm going to inherit from persistent connection. Okay. And in this case, now I don't have to define methods which a client can call to the server because we don't have those abstractions anymore. What I have is basically raw methods of sending and receiving. So I'm going to override on received. And I'm basically going to call, I'm going to return connection. And so connection is a connection, and I'm going to broadcast it to all the connected clients. I'm going to pass in the data. The other arguments don't matter. So that's my server-side code with connections and persistent connections. In my client-side code, things are going to slightly change as well. So if I add my index page, again, I don't have any server-side code in the HTML page, so that's why I'm calling it HTML. I'm going to, oh man, I don't like this feature. So I just want to drag jQuery and jQuery SignalR onto the page. And since it's a chat application, the primary HTML elements are going to be an input field where I can enter my message and a text box to send my message and something to display the results in. So I'm going to say input ID equals message. And I'm going to say input ID equals send. And so this will be of type button. And this will have a value send. Okay. And then I need something to display all the messages in my text window. So I'm going to create a UL, and I'm going to add results to it. So that's my HTML. In terms of my script, this is what it would look like. So notice I'm no longer including that magical /SignalR/hub script because in this case there is no runtime proxies being generated. I am going to create a connection, and I'm going to use a connection overload of creating a connection. So before I do that, there is one piece of code I have to change on my server side. So if you remember, for my hubs, I did not have to add any routes for it. And the reason I did not have to add any routes for it is because when I downloaded this application, it put this file into my project, which basically calls this map hubs API. And map hubs API basically sets the default route for SignalR, which is /SignalR, basically. And so once I start going the routes of persistent connection, I need to define my own routes as to what route maps to this particular persistent connection. So you can think about this as being routing. So I can come to route table, routes dot map persistent map connection, chat connections, and I'm going to give it a name. So this is chat. And I'm going to give it a URL that I can call it with. So in this case, if I go to my application and do my root/chat, I can talk to my persistent connection. So I can now switch back to my JavaScript, and I can say /chat. So this would map to the route that I just configured for my application. Okay. So I have my connection, and now I need to listen for any events from the server side into the client side. So I no longer have those nice APIs of calling a hub method on the hub. I basically have to call connection.receive. So this method will get called on the client side each time a server sends a message. And I can just define a function which sort of takes in data And that should be it. Wait. Yeah. Okay. And what happens basically, so this method gets called each time somebody sends a message over the chat application. And I just wanted to add these results to my window. So I'm being lame over here. What I'm going to do is I'm just going to append the results to my ULs. I could have been smarter by using knockout views and data binding and doing all the magic, but I am just doing a string append over here. So once messages keep coming in, they'll sort of start getting appending to the LIs over here. Okay, and similarly to what we did on the hubs, before we send any message on a SignalR connection, we need to make sure it's started as well. So we're going to start the connection. It's connection.start. And then I'm going to call done. Function. And so in my move shape, I did a draggable event. In this case, I'm basically going to listen for any click events that happen from this send button. So each time I click, I am going to send a message. I'm going to call this function. And I'm going to send a message over the SignalR connection. And the value of this message is going to be the value of the text box, which is message.val. Okay. So if I have everything right here, let's see if this works or not. So I have my two browsers. This is IE. This is Chrome. So there. So I have my chat application working as well over persistent connections. And in terms of the amount of code, like it's the same. It's about these 10 lines on the server side and about 10 lines on the client side and 5 on the server. So what sort of gets, yes? Perfect. Just hold on to that question. I'm going to come to it about 10 minutes from now, where how we negotiate different protocols. So the key difference I wanted to point out in terms of connections versus hub is like, so let's say in my application now, I wanted to add basic echo functionality. And echo is basically I send some data and I get some data back onto the same connection as well. The reason it gets sort of harder in this particular case is since we are only dealing with strings, we have no way of sort of differentiating this information. So I can create another button called echo. And once the connection starts, I can sort of send the message. So it's sending the message at the same endpoint on my persistent connection, but now I need to sort of differentiate between these two message types, the send and the echo. So I'm going to invent my poor man's dispatching by sort of tagging these message with a keyword which the server can understand. So I can do echo, and then in my server-side code, now I have to sort of parse the data and say if data starts with send colon, then just return this data. Else if data dot starts with, and then echo colon, then do not broadcast this data in this situation, but what you have to do is basically send it back to yourself. So connection dot send. I can pass in the connection ID, and then send the data. If it's neither of them, then just return, basically. connection, something like unknown message type. Right. So go back to the browser. 5, send, echo, echo, echo. So then it sort of stays with the same browser itself. But what sort of got a bit more uglier is the code that you have to write, because now you have a single endpoint where your whole app will call to. So it becomes a bit more problematic to sort of figure out what to do about it. So that's kind of the differentiation between a persistent connection and a hub. Like a hub is a very cleaner implementation in terms of an application model, whereas persistent connections now like it gets dropped down and you have sort of more control on what happens on all the events and stuff. But you sort of lose that nice and clean application model. So let's switch back to our slides. Connections versus hub. Connection lifetime. So what's interesting over here is basically when a connection starts between a SignalR, a client, and a server, a lot of things can happen. There's no physical connection that exists. It's only a logical connection between a client and a server. Like there's no physical connection that happens. So what that means is basically anytime sort of an event gets raised, for example, you close the browser, like it's got a clean teardown of the request. So there'll be events that will get raised on the client side and the server side that the browser got closed. So you can handle these events and do something with it. So, or other examples are, let's say if I have my laptop and I sort of close the lid down, so it goes into sleep mode. And that's what we call a forceful abort. So in this case, what SignalR will think basically is that the worker process sort of has gone down, and it'll keep retrying. So it'll keep retrying to connect until it sort of fails. And once it fails, it'll sort of raise events to the server side so the server can handle it sort of gracefully. So SignalR has these nice features sort of built in where you basically can retry up till a certain point for these requests. Reach. So let's talk about reach. And what does that mean? So what I've shown you so far was SignalR working with WebSockets. And this was great because I'm on IE10, I'm on Windows 8, and WebSockets is supported on these platforms. But on a global reach, the support for WebSocket kind of means what's there on the left-hand side of the slide. If you need to be on ASP.NET 4.5, your server has to be Windows Server 2012 and above. All your clients should be on the latest browsers. You have to be on Chrome 50. You can't use Chrome 5. It won't work. If you have load balancers along the way, you might have client-side proxies, and these are known to have issues with the WebSockets. And everybody that's connected in this application should have the same version of the WebSocket protocol. If anybody has a different version of the WebSocket protocol, then WebSocket will not work. And you have to manage scale out yourselves, because the way WebSocket is right now, it's not easy. So these are all sort of the limitations that WebSocket has. And the way SignalR sort of works around it is SignalR works everywhere. It doesn't matter what the client supports or what the server supports or what combination of clients are there or what combination of servers are there in the play. SignalR will work everywhere. And the reason SignalR will work everywhere is because it has a fallback mechanism. It tries to figure out like what does the client support, what does the server support, and then it falls back into one of the following protocols. It either uses WebSockets or server-side events or forever frame or long polling. But what it guarantees you is any point, your application will stay connected, no matter what the client and the server support. So it takes away all the plumbing required to make your application work across the whole world, basically. And that also makes it possible for SignalR to sort of scale out to web forms as well. So let me show you how this happens as well. So I'm going to go back to my application. And let's see what is open here, my chat app. OK. So let me do an F5. So yeah, perfect. So when the first time a connection gets established between a client and a server, following is the request that comes from the client. Like we have a connection ID, which is a GUID, a connection token, that's what the signature. And we have some variables that we keep, like how much should the disconnect timeout be, how much should the keep alive timeout be. And keep alive is basically a ping that the server sends to the client to make sure that the connection keeps open. So that takes care of all the proxies that happen in the middle with WebSockets and stuff. The protocol version says, like, this is the protocol version of WebSockets, and the key flag is try WebSockets is true. So SignalR thinks that either the server or the client can support WebSockets, so it sets this flag. And once the request goes to the server, then the server, if the server also supports WebSockets, then the WebSocket protocol will come into the picture. So the next request kind of sort of highlights what I was saying. So the negotiate one was try WebSockets. And the next step that happened was a 101. So 101 is a HTTP protocol version, and that signifies the connection has been upgraded from HTTP to WebSockets. And any transfer of data that's going to happen from this point onwards will happen through WebSockets. So this is the WebSocket support that was added in ASP.NET 4.5 and in iOS 8, which is like Windows Server 2012 or Windows 8. So that's how the connection happened. And so this is the negotiating part, where it'll go, if there's a mismatch, then it'll fall back to the next best protocol that both the client and the server can support, and it'll keep falling back until a connection succeeds. So that's how SignalR manages to work everywhere. And also something which is interesting is, if I sort of zoom out, let me send some data, send, go back, come here, zoom in again. So Chrome has this nice feature where I can inspect the WebSocket frames that are going over the wire. So in this case, my chat application is sending this send WS data, and the green ones are the ones that are sent by the client, and the white ones are sent by the server. So since I'm using persistent connection, everything is basically a string over here. But if I were to switch to a demo on hubs, for example, this one, we have 12, move, show my connection, okay. So if I inspect the traffic over hubs, so now you would see that now I actually have the method names that get called and sort of the data that's getting transferred. So green is something that the client sends, and the white is the one that sort of the server sends. So invocation 0, 1, 2, 3, and in the following ones, I basically see somewhere that invocation 3 got executed. So I can keep track of basically what's happening on the client side and what's happening on the server side as well. So that's the other difference of using hubs versus persistent connection as well. So you can get different features out of it. So let me go back. Questions? Okay. Transport negotiation, we just covered that. Reach. The other aspect of reach that I think is getting a lot more attention now is platforms and devices. Like, we no longer can say if it works on browsers, we're all good, we're happy, and let's make that happen. I think what's happening now is, like, with the explosion of all devices across like iPads, Androids, and Windows Phone, it's very important for us in a real-time scenario to have support for such a platform. So what we have right now is we have JavaScript clients, which I just showed you, so you can write applications for the browser, and they work across all browsers, across different versions of the browsers as well. The clients work for .NET Framework 4.0 and 4.5. We have a client for Silverlight 5, Windows Store apps, both HTML and HTML, JavaScript, and C#, Windows Phone 8. We're going to have a portable class library with the 2.0 release. We also have clients for MonoTouch and MonoDroid. So the SignalR source code by itself is open source. It's on GitHub. So there's a fork of the SignalR source code which works against Mono as well. In the future, what we will be looking at based on the feedback that we get is like creating some C++ clients, a pure JavaScript client which does not have any dependency on jQuery, iOS native, I don't know, like this list sort of goes down way further down. But on the left is something that we have very concretely today. And I'm going to show you some demos of these mixed client to give you an idea as to what the application model would look like. So the goal behind this experience is going to be that irrespective of what clients you target, you would end up writing the same code in terms of how do I start a connection, how do I send data over SignalR, how do I receive data over SignalR. So that's the overarching theme in these clients. So I'm going to open a project. SignalR demo. So this is the move shape demo, which we just saw on the browser. Only in this case, there's a desktop client to it. So my hub is basically, the core method is the same. I have some extra methods to handle connect, disconnect scenarios. In my desktop application, I have a reference to a package called Microsoft ASP.NET SignalR.client. So this is a package that works across different devices. So it works for Silverlight, for WPF, for Windows Store, Windows Phone apps. So it has a DLL for each one of them. And my code to actually call this would look like this. So I create a hub connection, and I can create a proxy over here. So since this is not JavaScript, we cannot generate at runtime the proxy that we used to generate for /SignalR/hubs. So we have to create the proxy myself. I could have written the same code in JavaScript as well. It would have worked, and I'm going to show you in the next demos. The hub on is basically gets called whenever the server fires a shape moved event. So remember, in my browser, this was the JavaScript method that I wrote, which the server called. In my desktop application, this is the Lambda that gets called whenever a server fires the event. And when a server does a hub.invoke, so this calls a method from the client application to the server. So that's how it happens. Let's run this application. So let me browse /move shape. Let me kill that. I'm going to use Opera mobile emulator for this demo. It's a great tool for trying out how your applications look on mobile browsers. And the last thing I wanted to start was the desktop application. Okay. So now I have 3 clients. Okay. So I have a little counter as well saying I have 3 clients. And the move shift demo kind of looks the same. I can move across all these clients. What's interesting about this demo that I wanted to highlight was, so Opera Mobile has a bug where if you close this emulator, it does not fire on disconnected or on closed event. So SignalR cannot listen for that event. So if you notice in my hub method over here, I basically had some code to execute on disconnected, on reconnected events. So SignalR cannot handle those events because those events don't get fired. But if I close this browser, SignalR thinks that one client has disconnected, so it'll keep retrying, and eventually it will give up, and it will drop that connection. So if you notice, I have a counter for the number of clients that are connected. If I close Opera, this counter does not get updated immediately, but this is the part where sort of SignalR is trying to connect, retry, and after a certain point in time, which is about 10, 15 seconds, this counter should sort of drop down down to 2. So you're going to wait, maybe, 2, yes, it dropped down. Okay, so that's an inbuilt feature for SignalR as well, where it tries to retry, and it gives up after a certain point in time. Okay. It is now time for some exercise. Who wants to be the volunteer? I need a volunteer. So I'm going to show you the move shape now with Kinect. So you might want to stand like about 6 feet, a little back, yeah. Okay, move your hands. This is the same demo. Like I have a SignalR hub on the server, and I have SignalR running, which is connected via Kinect. And so somebody can sort of control these applications and have some real-time feedback on this particular case. Thank you, sir. Round of applause. So in terms of my actual code, my move shape web application is basically my hub. It's the exact same code. My JavaScript is going to be a bit different. So remember, like in the last demo, I showed you that how this is going to start using the create proxy methods instead of dynamically generating these proxies at runtime. So the code between a JavaScript client and a .NET client can look the same. So if I open my Kinect application, so let me compare these two side by side as well. Okay. So on my right is basically the call to create the connection. On my left is the same call in JavaScript. On my right is, let me give the on method. So let's look at hub.invoke, so which is calling from the client to the server. And in my JavaScript, it is basically the same call, hub.invoke, pass left and right. If I keep scrolling down, let me do on. Okay. Oh yeah, that's only one way. Yeah. So that's the overarching theme between the clients as well, that once you start going down this path, your API programming model will look the same. So no matter where you're coding in, like console applications, like Kinect applications, phone applications, store applications, you sort of follow the same pattern. So you have a lot of transferable knowledge that you take on forward. Let me show you a different client as well. So I'm going to show you a Windows Store application. So I'm going to open my project, and I'm going to show you a chat demo. So I have already published my app to Azure. So I'm going to just load up this app. It's just a simple chat application. I'm going to start the Windows Store application. It started. Okay. So let me refresh. So again, hello from web, hello from web, hello from Windows, hello from Windows. Again, the same real time is happening between now a store app and a browser. And if I just quickly jump back to my store application, the code will be the same basically. I create a hub connection, I create a hub proxy, then I have my on method, which basically is the receive message that gets called from the server to the client. And then I have my invoke, which is basically called from the store app to the server. So again, the same model keeps on following us wherever we go. So a cool thing I wanted to show you about SignalR is about, so remember I was talking about retry attempts. And so in this case, I'm going to try to simulate an experience. So I'm going to start an iPhone. And so what I have is I have an app. Oops, wrong URL. Back. Come on, yes. Okay, so I have these two clients connected. Like one is a phone, one is a browser on the phone, and one is actually the real browser. And these two people are sort of chatting with each other. Hello from web, hello from iPhone. And I'm going to simulate what happens when I sort of disconnect the network. So I'm going to try to be brave. I'm going to say disconnect. And I'm going to send some messages from my client. And let's say the server connection comes back. So what's going to happen is if it came back at the right time. Oh, somebody is sending messages from Spain. From Norway. You guys broke my demo. Okay, so what would have happened basically is these messages get queued up, and once the SignalR connection comes back, it would have buffered all the Bs, and then I would have got these messages as well. I think a point being, like, somebody must have messaged these while the connection was down as well. And hello from row 3. Who's row 3? Okay, so the scenario here was basically if a physical connection goes away, which is where I sort of disconnect from the network, there's a retry loop in I have a red one. It's the awesome. And so there's a retry logic in SignalR which sort of kicks in, and it keeps on retrying until the connection comes back, and it buffers all the messages. So you don't get messages lost. I think that's the point I was trying to make in this demo as well. All right, U2U. Pablo, I do not understand that. My Spanish is not that good. Okay. I think that's the question I'm surprised nobody has asked yet. The connection IDs are internals.
Yeah, I know, but you're sending to a specific, instead of broadcasting, you're sending to a single one with connection ID.
Yes.
On the hub for you.
It'll change, and SignalR will handle that.
That specific connection ID is not connected anymore.
Right.
Do you get an error on the hub that it's not there anymore? How does it react?
Yes. You get an event that's raised, and you can handle that event. That the client is no longer away, is away or something like that. Okay, so this was amazing. It's an amazing technology. Let's just start using it. Let's start writing applications. So the point that sort of comes to, as it came to my mind, at least when I first started using it, was what about throughput? What about scale? What about performance? Like, what you're asking me basically is to open up so many connections on my server. I think I had not dreamt of doing that ever. Like, I thought that was a bad practice. It's going to slow down my server. Like, so what are the numbers? Like, does it really work? So I think the message that we're going to put forward is basically ASP.NET does deliver a very high performance on a single box. It has, and the reason sort of SignalR can utilize that is because SignalR is async all the way up. So each time a connection gets opened, at the server side, there is a SignalR connection that opens up, it processes it, and it goes back to sleep. And it's basically idle. So it's not utilizing the CPU resources. So that's the beauty of it. Like, so SignalR is async all the way. It utilizes threads as little as it needs. If there's no work on the connection, then the threads go idle. It's sort of in a sleep loop. It does allocate some memory because it has to track some state on the particular connections, but that memory that it allocates is fairly low. In general, what has also happened when we released .NET 4, IIS and ASP.NET had the setting of like about 5,000, which is the number of concurrent connections that you can keep open. So that limit changed between what we shipped with .NET 4 and .NET 4.5, simply because like newer technologies came up, WebSockets came up, which warranted this default value to be like bumped up. And this default value is configurable. You can go and tweak these settings. And if you go to the SignalR GitHub project, there's a whole article on how you can run the tools of Crank and how you can measure performance, how you can measure scale, and how you can measure throughput. And what we observed in some situations, like we've seen about 500,000 connections on a single box. What we plan to do going forward is like we do plan to publish like very concrete white papers on if I were to optimized for chat applications or real-time gaming or my real-time collaborations, and I would start scaling in Azure, like this, these are the numbers I would get, and this is how much would cost me. So that's something that you should expect out of our team, like going forward. And the last thing is basically I want to touch upon is scale. So far what I've shown you SignalR is about a point-to-point communication. I have a browser and I have a server, and that's it. I only talk to that server. Like what happens in a web farm scenario? How do we scale out? If I just put my application and sort of scale it out to different servers, it just will not work because SignalR by default is only a single server point-to-point mechanism. And the reason the way we achieve scale out across web farms is by by the notion of having a backplane. Have people heard this term backplane before? Okay. So let me explain you a bit on what happens. So let's say this is my web farm setup. On my white triangles are the clients which I've connected to these servers, and these servers are sitting behind a load balancer and something, so this application will get scaled out. If and the application gets, all the servers get connected through what we call as a backplane. And a backplane is a term is basically to connect all the servers at the back end. And so what happens is, let's say if this client over here sends a message to a particular server. Instead of sending a response immediately back to the client, what the server does is basically a server pushes this message up to the backplane. And when this message goes onto the backplane, it's basically a messaging bus. And this backplane replicates these messages across all the servers. And it pushes the messages down to all the servers. And all these servers then push the message down to all the clients as well. So the integrity that we maintain is the backplane. Like the backplane is the single authority to say how messages go from one client to the server infrastructure back out to all the clients. We never short-circuit this route to say if this client sent a message to this server, the server sent it to the backplane, and then the server also sent a message back to the client. Like that will never happen in the SignalR system because it will break scale-out. So that's how scale-out kind of works. And let me show you how you can enable your web application for scale-out. Going to the country drink, yes, absolutely. Bond, James Bond. Guys are funny. So I'm going to go to asp.net/SignalR. This is where all the documents are sort of hosted. And we are in our UE team, our documentation team is in the process of writing more detailed tutorials. But what I wanted to show you was for performance and scaling, like we have the following options of you can scale out using SQL Server or SQL Azure Service Bus, or you can scale out using Redis, which is an open source platform. And the beauty of this lies over here. So let's say I wrote my chat application as I just showed you, or I wrote my move shape application as I just showed you. To enable scale out across web farms, all I basically have to do is come into my application, and in my global ASX or my app start where I was registering map hubs, I basically have to call these two lines, and that's it. And my application will scale across a web form. So I don't have to change the application code that I wrote. Everything stays the same. I just change how scale out happens. So that's how, again, simple it's going to be to sort of configure your applications for scale. Yes?
Have internal role communication so that you would skip the whole backbone. So when a message arrives in an instance,
Right.
it would call the other instances that are under.
No. If you have a system set up where you have multiple servers, it'll always use a backplane to synchronize all these messages. So yeah, there's always going to be a backplane in the picture. So, okay, yeah. So that was the code to enable scale in your sort of applications. So let me jump to the next slide. It's pretty much the last slide. So the other unique thing about SignalR is also it's it has no dependency on system web. And so by that, what means is you can run SignalR outside of the context of ASP.NET. And the reason that is sort of important and possible is because it's hosted on Open, which stands for Open Web Interface for .NET. So it's a new interface that defines the pluggability model for different .NET applications. So SignalR is built on Open. The next version of Web API is going to be built on Open. So that means that you can host both SignalR and Web API in your own process outside of a web host. Some trivia as well, like it's an open source project. If you have any suggestions for features, you have bugs, you can log them on GitHub. That's where the team has an open discussion on any of the feature requests. It is also the #1 watched C# project on GitHub, I think, which is a huge outlook on the .NET community that's out there. And SignalR became part of the ASP.NET framework with the Visual Studio 2012.2 release. Up till then, it was being run as an open source project, but now it's a fully supported Microsoft project. You can call PSS, and they'll walk you through like the normal support holds valid for SignalR as well. So that's something big that has happened in the recent months for SignalR. What else do we have? And there are some related talks that you can go to. There's a Web API talk tomorrow. There is a deployment talk that I'm doing tomorrow as well. These are some slides which I have no information about, but I will definitely run through them. Please make sure you read these slides. Do complete the evals, so it does help us out a lot. So if you guys have any questions, I'm going to be hanging around over here. I'm going to be at the booth as well. I'm going to be at the Ask the Experts tomorrow. Okay, questions? Are you guys still alive? Yes, thank you. Right. Right. Yes.
That means that we have to manage kind of the connections on the hub to map the connection ID to the credentials, the specific login name. What about scaling in that fact? Because right now we're doing this in memory. I don't know how to scale it up. You see what I mean?
Yes. Let's chat offline on this. We have new support that's coming in for the authentication stack that should alleviate some of these concerns. So let's talk about it, like that feature. All right, thank you so much for, we have one more. You can drop it. So thank you so much, guys, for sticking around. It's been a pleasure talking to you about this.